Charles' law is very similar to Boyle's law. It just deals with different variables and different constants. Our variables, things that change in Charles' law, are the volume and the temperature. The constants would then be the moles and the pressure. So those things aren't changing. So our equation for looking at starting out what we had written before, our pressure and moles are constant. So P1 and P2 are the same, and then N1 and N2 are the same. So our equation would be V1 over T1 equals V2 over T2. Now we're dividing in this case. So in order to get the same value each time, if the volume increases, the temperature would also have to increase to get the same constant. So the relationship, as one increases, the other also increases. Or as one decreases, the other also decreases. This is not inverse. Inverse is opposite. This is a direct relationship. So let's do problem number 6 in your packet. A sample of gas occupies 230 milliliters at 15.0 degrees Celsius and 750 torr. What volume will the gas have at 20.0 degrees Celsius and 750 torr? So we have a volume of 230 milliliters, an initial temperature of 15.0 degrees Celsius, an initial pressure of 750 torr. What volume, so V2 is what we are looking for, will the gas have at our new temperature of 20.0 degrees Celsius and our new pressure, or our same pressure, sorry, of 750 torr. Pressure didn't change, so we're going to ignore it. The only thing before you go to this equation is temperature. Temperature in all of our equations, just like in ideal gas law, must be in Kelvin. So for each case, Kelvin is always higher, so you are adding 273. So the initial temperature is 288 Kelvin. And our final temperature is 293 Kelvin. The reason they have to be in Kelvin is Celsius, you're going to get negative numbers. You also could have a temperature of 0 degrees Celsius, and temperature is in the denominator, and you cannot divide by 0 and get an actual number that we could work with. So our equation is V1 divided by T1 equals V2 divided by T2. Most students in solving these find it easiest to cross multiply and work from there. So they would start out by multiplying these. So you would get V1 times T2 equals V2 times T1. Be careful with the subscripts again. Solving for V2, so I'm going to divide both sides by T1. So V2 equals V1 times T2 divided by T1. So the initial volume was 230 milliliters. And it's okay to leave this in milliliters as long as your answer is okay to be in milliliters. T2 was 293 Kelvin. Again, make sure you're writing your units so you can check that your answer is correct. And your initial temp was 288. Since this is a direct relationship, the pressure, or the temperature, sorry, went up. If it's direct, the volume should also go up. So we should get an answer larger than 230. Punch this into your calculator. Get your answer. My calculator shows the answer as 233.99, etc. All three of your numbers have 3 significant digits, so your answer can have 3 significant digits. So I have to round it up to 234. Kelvin divided out, so it's milliliters, and that is larger. So there's my answer.